Powers of I. Okay, this is kind of interesting. We're going to show you that I should never be raised to a power. So we know that I, square root of negative 1 is I squared is negative 1. I cubed, and I'm going to go through this kind of fast, so if you got to pause the video, so be it. That's I squared times I. Wait, I squared is negative 1 times I. That's a negative I. Wait a minute. What am I doing? Oh, I'm sorry. This is your exponential rule. Products, base times base. Multiply like bases, add your exponents. If you want to put a 1 there, put a 1 there. 2 plus 1, 3. I squared times I squared. That's I to the fourth. Always using something I've already created. Well, that's negative 1 times negative 1. That's positive 1. Oh, another real number. I to the fifth. Use what I've used. I to the fourth times I to the first. Wait, I to the fourth was a 1. 1 times I. I to the sixth, I to the fourth times I squared. 1 times negative 1, negative 1. All right, you know where I'm going. I to the fourth times I to the third. I to the third was negative I times 1, negative I. I to the eighth, okay, I to the fourth times I to the fourth. 1 times 1 is 1. It's the same answers every fourth power. We can keep doing this. That's crazy. But I do want you to notice a pattern here. Look at all the odd powers. I to the first, I to the third, fifth, and seventh. The answers are all I's, either positive or negative I. Now look at all the even powers. 2, 4, 6, 8. It's either negative 1 or positive 1. So, let's build a rule. To simplify I to the nth power, the first thing you look at is the power. If the power is even, it's either a positive or negative 1. We just got to find the sign. If the n power is odd, then it's an I, positive or negative. We just got to figure that out. Now, how do we figure that out? Oh, we use a rule that you've been using for quite a long time. If I multiply two negatives together, it's a positive. If I multiply 4 negatives together, it's a positive. If I multiply an even number of negatives together, it's a positive. And if I multiply an odd number of negatives together, 1 or 3 or 5, it stays negative. So, ding, take the n, divide it by 2. Why 2? We're trying to find out just how many I squareds, how many negative ones are factors. Now, if you get an even whole number, because sometimes you get a 12.5 or a 28.5 or a 36, the whole number. If the whole number is even, that means you're multiplying an even number of negatives. That's positive. If my whole number is odd, an odd whole number gives me a negative. So now I get like 7.5. Okay, that's 7 negatives being multiplied together. That stays negative. So example down here. I to the 21st power. Okay, 21, that's odd, it's an I. Left some space here to put my sign in. Take the 21, divide it by 2, 10.5. Okay, just want the 10. 10's even, it's a positive. Put a plus sign there. I to the 80th power. That's even, that's a 1. 80 divided by 2 is 40. That's an even. Put a plus sign there. Now, negatives, exponents are crazy. If it's a negative even power, you can still use this rule. Okay, it's an even, it's a 1. Negative 14, the 14 divided by 2 is 7. It's going to be negative. Now, why didn't I say negative 14? Okay, great question. Because the negative just changes the location of the base. So, add this to this example. I to the negative 14th is the same as 1 over I to the 14th power. So it doesn't matter if it's in the denominator. Okay, 1 over 1, because it's even. 14 divided by 2, 7. Okay, makes this negative. 1 divided by negative 1, negative 1. However, what if I have I to the negative 15th power? Now that rule doesn't work. Why watch what happens. 1 over I to the 15th power. Okay, that's odd. 1 over I. 15 divided by 2. 7.5. 7. It's a negative. Oh, there's my problem. Wait a minute. I cannot have I in the denominator. So what did we just say? You have to rationalize the denominator. So now I'm bringing in another I. Okay, wait a minute. That's going to give me I over negative I squared. I over negative times negative 1. This becomes now a positive I. So you got to be careful here. Negative exponents, put it in the denominator is the smartest way to approach it. If it's an even negative, you can just apply the rule because you're going to come up with that negative. There's no extra i's. Everything simplifies away really nice. But if it's an odd, put it on the bottom. Use the rule for the denominator, but then you're going to have to multiply it by an extra I over I. Well, that's going to turn it then technically into an even number. That would be like saying I over I to the 16th power. And that generates a positive 1. And there's your positive I. So this is the rule I would use if you have I to a negative odd power. All right. 6.2.